Let us start. We'll conclude in next 1 hour, right? And I hope this 1 hour will be most interesting. If I know all we know the things, but what most of the things we know, but I just want to do a quick recap so that when our subsequent session will go, we can understand more better way. I hope my screen is visible. All
Yes.
okay? Great.
Yes.
Okay. Okay. So let us start with a very simple thing, right? The human, right? Why human is the best, best species in the world. The question has come today when I was, giving some teaching to my daughter. So she was telling that why not a dog can do it, right? A dog can be well trained, that is correct. But dog does not have all the things which a human has. So what are the things human, things are there which human made special? So it can take input, right? Ear, eyes, etc. It has a memory. We can, remember the things. We can do the processing. If somebody asks something, we can do the processing and then we can think, right? What should we do? We can do the prediction. That is also important, right? Based on the information, we can say that, okay, what could happen, right? We can do future prediction, right? We can take decision. Yes. So decision is very important for a person. You may have multiple options to choose for your career path, but you have decided, no, I should be going in the science division and then the engineering and etc. And based on the decision, you take the action. So action is important. Without action, nothing will happen. You take decision, but without action, will not be rewarded, will not get recognized. So action is important. Execute the plan. And definitely while you do all the things, right, we are taking the feedback. Our work has been evaluated. We are getting recognized. We are getting appreciated, etc., etc. And so basically, this is a human intelligence is happening. So people were thinking in earlier days how we can do some similar kind of things in for a machine, right? So all the terminologies which we have seen now, like input, memory, processing, prediction, decision, action, feedback, all are nothing but the AI terminologies. So it's very similar analogy which we want to give it to here so that we understand, right? And update memory. So what is important is memory. If your memory is limited, right? Every human's memory is limited. Every computer's memories are limited, right? So people generally, if there is a older information, people forget, right? If there is no new information, so if we don't study from the internet or from chat gpt or from the newspaper, we'll keep forgetting the things. So it is important that we should update our memory, right? So define the knowledge base. So need to know the new things, etc. So those are the things. So get the feedback, update the memory and give it to input. So those are the things human does. And human was thinking, why not we can apply all these things into a machine so that machine can perform the similar kind of things. Let's go to the next slide. Not moving. Okay. Now let's see what is machine. So in machine learning, when we'll be studying, the key thing is before this slide, I want to cover one important slide. Is the history. History. Just 1 minute. We need to just do a little bit of history of machine learning. Uh, history slides is there. Okay. Yes, this is the slide. So this is the evolution, right? In 70 years transformation, right? People started thinking about AI. Very, very interesting thing. People started thinking of AI in 1950, before our birth, right? Human intelligence exhibits by machines, right? In 1980 is the machine learning which is starting, right? So 1980 onwards, people are thinking why not to put a machine, right, which will behave similar like human beings. Even when we are doing engineering, there was a computer science department, there was a IT department where we are studying about the AI and machine learning. So in 1980 the machine learning journey started. 2010 the deep learning started. We'll study everything, right? So we'll be talking today on AI, machine learning, different algorithms, and then we'll be quickly going to the deep learning, and then we'll be studying about the generative AI, then the new concept which has started very recently, which is the agentic AI. So all these things which we'll be studying one after another, and we'll see how these things are evolving and why we should evolve. But the basic fundamental thing is whatever we have seen on the first, on the first chapter. Any questions?
No.
Am I making sense?
Yeah,
Yeah.
no
Okay.
questions.
Okay, let's move on to the next. Right now, we'll be talking today about the more on the machine learning. Right. So let's see what is machine learning. Right. So very simple. Machine has an input, as we have seen, and machine will give an output. Very, very easy thing. So if you give some input, you will expect some output. Right. So say for example, let's take a couple of examples. Right. So first thing is that suppose you have some kind of just think about a baby. Okay, it's very easy to understand. So in front of baby today, you are showing, okay, that banana. So you will tell that this is banana. You are showing, asking the baby first, what is this? Baby does not know anything. So he can say apple, you can say guava, it can say mango, etc., etc. But he will tell, no, no, my dear, it is banana. So tomorrow when you will ask, the baby will say it is a banana. So that is the beauty. So baby has learned. So similar way, if you can say that, okay, this is banana, this is mango, this is apple, that means you are actually labeling it, right? You are labeling it and you are asking machine to say, what is this? So then machine can predict and say that this is what? This is banana, this is mango, and this is apple. So a machine can differentiate it. So how it happens basically in this world actually. So this is called the supervisor learning, where you are actually said that these are the labeled data and you are train the model with the various kind of data and you are getting the output. Let's take an example from this picture. Actually, this picture is very interesting picture. If we see it, you can see the beauty. Not this one, rather than this picture. Have a look on this picture. So this is very interesting picture actually, right? Forget what is written in the right side. Concentrate on this picture. So what we are saying that, see, this is the label data, multiple label data which we have given here, right? And we have given two kind of data. We are saying that, okay, this, and there are label data of this as well. And you are actually sending this information to a supervisor learning, to an algorithm, and the algorithm will do some kind of pre-processing and it can identify these three things actually. So pre-processing is very important because here are multiple duplicate informations are there. So what you are doing in the pre-processing, actually you are removing all kind of duplicates and you are identify three different categories, right? And then your output will come, okay, this is elephant, this is camel, and this is cow, right? Because you have explained it here that this is cow, this is elephant, this training data is the label data, but here you have not mentioned, but these are different count of cows are there. But based on this algorithm, based on this algorithm, you can understand that there is only distinct cows are there, distinct elephants are there, and distinct camels are there, right? So based on that, it actually it can identify. It does a pre-processing, remove any kind of space, HTML markup, or any kind of noise, etc. And then finally, it can predict that this is elephant, this thing. If you can show it's the elephant, it can now predict this is the elephant. If you show camel, it can say camel. If you show cow, it can show cow. So this is the picture actually saying. So this is the supervised learning because you have labeled it, you have trained the model with a various much of data, and then you are actually asking the question. Make sense? So this is like a supervisor learning. Today, we'll be talking more about this supervisor learning. We will call it's called the linear regression. That is our topic for today. And if we can get time, then we'll be talk about the logistic regression also. Probably today we'll be covering up till linear regression. It's very important and very interesting thing. And next day probably we'll cover logistic regression. Otherwise, it will be heavy for today. Okay. So what is my main objective here is, before we go to the linear regression, we need to understand what are the different kind of supervisor learning is there. Supervisor learning means somebody is supervising you, somebody is guiding you, right? So there are two kind of supervisor learning is there. One is the classification, another is the regression. So classification example I have given to you already. If you are showing apple, then this is the apple. If you are showing banana, then you ask the machine, it will say banana, etc. Whatever picture you have seen. But what is regression? Regression is which is going continuously. See, for this is very important point I'm telling to you guys. So classification means when you are talking about category. So you are categorizing the things, right? You are saying this is cat, this is dog, this is elephant, this is camel. So you are categorizing. When you are categorizing, it is called a classification. What is regression? Regression is when the things are continuous. Like house, price of the house. It is a continuous thing and it increases, right? So that kind of things, it's called a regression. You can ask what is the stock market price. So this is a continuous thing. Can you predict a stock market price for a particular brand? So it is the continuous thing. When it is a continuous thing, there is a regression, right? Clear? No, any confusion, any question? So we are talking about two things, classification and regression. Regression is the continuous thing which is happening. What is the temperature? It's a continuous thing. What is the, what is the speed of the wind? Right? This is the continuous thing. What is the house price? Can you predict a house price? Right? Based on this input, it's a regression. And the classification is something which is like label data. You are training the model and model will be answering based on it. Any question? Yeah. If no question, let us move. Classification, like here, we can differentiate which is spam and which is in inbox, right? So that is what it's saying. This one, yeah. So this is another interesting thing, right? So what we are saying that in supervised learning, there are multiple algorithms are there, classification, regression, unsupervised learning, etc. Within classification, the most important is the logistic regression. This is one of the things which we'll be studying in the next class. But today's class, will be talking about the linear regression. So we want to see that how the linear regression is working. And it is a simple mathematics. If we, Neha, I know you are champion in mathematics. I know Sri Lakshmi, you have not done much on that, but you will be learning it easy because we all know y equal to mx plus c, right? I hope in our 10 to 12 time we have learned about the linear linear graph, right? So that is what it's coming, the linear regression. Okay. One more important thing is when we are talking about this linear regression or logistic regression, we need to understand we are actually predicting the things. We are asking machine to predict something for us, right? So that is what we want to cover in today's class. Any question? Okay. If we don't have any question, I hope, am I making sense, Sri Neha?
Yeah.
Yeah. Okay. Right. Okay. So
Yes.
few important thing I want to few important thing I want to cover here is human intelligence. Human intelligence has five very important part. There are many important part, but I am talking about the five because they are very much related with our machine learning experience. So what we are saying that it can adapt. It can very quickly adapt. So adaptability is very important. Adjust to the new unexpected events. Any new unexpected COVID comes, we have adjusted, right? So that is the adaptability. So when the machine learning model needs to be created, it needs to be adapt, right? That is very important. So suppose I'm giving an example, very important in today's world. When I am speaking with multiple customers, they're talking about this. So what is the example? Example is suppose you created a model, you created a predictive model. Okay, you are saying that what is the expected stock price for say 6th of April for a particular product, say Titan, say for example, or say Indian oil. Okay, so think about that time there is nowhere, right? Or today think about that we are getting oils from Russia, so we are fine. But in tomorrow, if we are not getting the oil, this prediction will not be correct for the machine, right? So what it means is the machine should be created in such a way so that it can adapt with the new unexpected events. That is very important. So while doing the machine learning things, we should remember that. That is the one of the important point. Two is generalization. So apply learning from one domain to another. So it's not that you will be getting all these informations and based on the data you will be trained. You will not get all the data together to get it trained, right? So whatever informations you are getting, if something new will come, your algorithm should support in such a way so that you can also predict the new things. So the generalization is important. Third is emotion integration. Decision is not purely logical. So all the times your decision may not be purely logical. It can be, it should be based on some kind of practical things also. So it cannot be purely logical, right? Purely logical means whatever code you are writing, so it should not adhere only this. There are few parameters like called bias, it's called relevancy, called accuracy. So all these things you should also remember while doing the two more important thing in this concept. I will say that it's called overfitting and underfitting. These are the two terminology. Just I want to touch base now. It is a big topic, but I'm just quickly touch basing on it so that you understand. So suppose we created a model. When we created a model, we should ensure that the model should not be underfitted, and it should not be overfitted as well. What it mean of the overfitting means that you have written some kind of complex logic within the model, so that the model is not able to predict the correct thing. It is actually hallucinating and giving some wrong result, okay, some due to some complex logic, okay. Or what we can think that you have given some kind of training data, and it has trained based on this, based on the trained data, but while you are giving test data, the model is not behaving correctly. So it's the overfitting. Underfitting is a model that in training time also model is not able to work well. In testing time also model is not able to work well. So it's underfitted, right? So this is what we are saying, that the emotion integration is important. It should not be overfitting or underfit. It should be well balanced. Self-awareness, you know that what you are thinking, right? So that is very important, that you should be confident what you are doing. So machine should know what machine is giving, and machine should have a memory which can compare from it and give the response, right? And long term goal thinking, so it should think on the long term things, 5 years, 10 years, etc. So these are the human intelligence, and the scientist wants to put all this intelligence into the machine so that it can give the right answer. So this is the overall analogy, and we'll be seeing those things in the due course. Okay, now let's move to the next topic, our discussion topic, which is the linear regression. Before going to linear regression, I want to give you another important information from here. So we know the supervised learning, classification we know, regression we know. Unsupervised learning means where there is no yeah, there is no training is happening, means no pupil, there is no level data actually. So based on
Label data.
yes, there is no level data where based on the pattern the machine needs to learn, and it can respond, it can give the output. So no label data, based on the pattern, so machine needs to find out some pattern, and based on that it will give. So that is unsupervised learning. In due course we will be learning all these technologies, and all these technologies when we'll be learning, we'll be doing some kind of hands-on also. I'll show you some kind of hands-on as well, so that you can learn. See, remember, the basic principle is very simple here. For a model, I'm telling you very summarized version, that for a model, we should know that first thing is that before you create a model, you should have a data. That is important. So let me go to this page, and then let me explain so that you can quickly understand. Yes, this is the very important page for all of us. It is called MLOps actually. Yeah. So first is, what is the problem? What we want to identify. Second is data collection. See, data is the base, right? Without data, we call it garbage in, garbage out. If you give wrong data, right, model will respond wrong information. So proper data, quality data is important for your model. Clear? Next, data cleaning. So quality of the data. So data cleaning is required. What kind of cleaning? Can you give some examples? Yes, the examples are very simple. If there is a audio data which you are capturing, you should avoid any noise. Okay. If you are capturing any kind of transcript data, you should avoid any kind of HTML marker information, right? So your data should be properly cleaned, and it should be integrated together. Next is feature engineering. Very, very important. Feature engineering means you don't need everything to the model, right? You need to identify what part of the information is relevant for the model, right? So rest of the things you please ignore, you please filter it out. That is what is called the feature engineering. Okay. Then is the model selection, very important. So there are multiple models. Why I am saying multiple models? Models can be created with the different algorithms. Different algorithm will give you different models. But which model is best for you, you need to select by seeing the accuracy and the error. So in this machine learning world, there are few terminologies which we need to understand. One is error, second is accuracy, third is evaluation. Evaluation is very important. So we need to evaluate the things in such a way so that we can identify which is giving perfect results, which is not giving the correct result. So evaluations is very important. We'll talk through everything today. Next is training. So we need to do the training of the model. And okay, so evaluation is mentioned here, and the deployment. Deployment, we call it as the inference. So when we put any models into the production, it is called inference. This is the new terminology. Please try to add it. Neha, makes sense. These are the terminology. Have you heard? Or this is means you are already aware about it?
Yeah, I read this. Yeah, mostly I know.
So you are aware about it. Okay, good.
Yeah.
It's a revision for you. And Sri Lakshmi, what about you? You also aware?
Yes, yes.
Yeah. Okay. All right. So another kind of learning is also there. Supervisor, unsupervised. We have seen. We have a reinforcement learning. In due course, we will be talking. It actually says that yes or no, whatever activities which will be giving, based on that reward and action mode, it works actually. Okay. So this is the reinforcement learning. We'll be going deep when we talk about the reinforcement learning. Okay. Data collections. All we know, different source, from the different source the data comes, right? And garbage in, garbage out, I have explained, right? So there is nothing new here. This very important point is mentioned here. Very, very important. Okay. In machine learning language, we talk about two things. One is feature, another is level. Okay. So basically X and Y. So you are giving some input, you are expecting the output. This is the first point, right? Which we have seen in the previous discussion. When you are saying we are giving an input, that is nothing but a X actually. When you are trying to get some output, which is nothing but the Y, the output variable target, right? So what you want to predict, right? An input variable, input variable is the independent variable. So you can give any number. What model used to learn? So you need to give the name of the model, and Y is output variable target, what we want to predict. So let's take an example, right? So suppose you want to, you are asking to predict. So again, the word predict is very important. It may be accurate, it may not be accurate, right? But the predict means you need to just judge, right? So you have given some input that okay, my requirement is I want 1500 square foot, I want 2 BHK, and I want location in Bangalore, just beside Neha's house, right? So these are the requirement you have given, and you are asking, okay, what is the price, right? So the machine should predict the price nearer to the actual. Then your machine, we can say that the accuracy or the efficiency of the machine is good. If it is not giving the proper result, that means if there is a difference between the actual and predictive values, prediction, then we can say that the model is not performing well. That means we need to look into the proper data again and see that why we need to investigate why the machine is not properly behaving. Okay. So that kind of things which will come in due course, but these are the features and levels. Okay. Let's move on. Okay. So we are good with these features and levels till this point, right? Now we'll be talking about the main thing, which is the linear regression today. Okay. Okay. So linear regression is what it does. Basically, it predicts a number, right? Oh my God. It predicts a number. Okay. So suppose you want to predict the house price, right? So the model will look into the size of the house, number of the bedroom, location, store, etc. And it tries to draw a straight line that best fits the data, right? If it is a bigger house, then you will get higher price. If it is a smaller house, you will get the lower price. But it is the concept, it is called y equal to mx plus c. You will see in due course. Basically, it is a draw a line and it will tell you that how much you are getting the correct result. Okay. So based on that, you need to identify the error. Based on that, you need to identify the efficiency, and accordingly the model will be giving the correct result or not. You can calculate it actually by using the Python code. Also you can do that. Okay, so let's see in the linear regression, a straight line formula, salary prediction, sales forecasting, demand estimation. So all these cases linear regression are being used. Now from here the most important things are started, right? So what we are saying, that you will be giving a x, you are getting y. Okay, all the things which we have discussed, you are seeing all these things together only now. Next thing is that, see, this is what we are saying, right? You have a x, you have a y, and you have got this line actually, and these are the actual numbers actually. Okay, now you have predicted something here. So what is the difference you need to calculate? We have predicted something here. What is the difference? But ultimately this actually the model, the algorithm will help you to get this line, and then it will calculate the error means nothing but the distance between the actual and the prediction. So this red line is the prediction, these dots are the actual. Okay, and you are actually checking how much is the difference between the actual and the prediction, and accordingly you will be deciding that how much your model efficiency is. Any question?
No.
Sri Lakshmi, you understand?
Yeah, yes.
Very, very important. Okay, see, this is
Yes.
what we are saying. This is the line, I'm repeating again. This is the line which we have got from the algorithm. This is the actual values, right? And we are saying how much is the difference. Whatever will be the difference, that is our error. Okay, that is our, what is that? Error. So actual minus predicted, right? Actual minus predicted equal to error. Okay, so that is how we calculate the error. So for this point, it is actually giving the exact information, since there is no error. Make sense?
Okay.
Okay, now this is an example actually. So some X information is given. This is the actual figure, right? And what it is asked you to do it, can you please calculate what is the predicted figure for it? Where your model formula is y hat equal to 2x, right? You understand what is the question? What is the problem statement? So they have given for X, this is the actuals. For 1, it is 3. For 2, it is 5. So these are the actuals. Whereas your model's formula is y hat equal to 2x. This is the based on this formula the model is created. Linear regression problem is created. Y hat equal to 2x. Then what is asking, how much is the y hat, right? And then we'll be checking how much is the difference or how much is the error. Okay, so let's see that. So 3, 5, 6, 9, and so if I have the x, then we have got a y hat which is 2, 4, 6, 8, right? Now, what we need to do, calculation is for 1, we need to see how much is difference. 1. For this 2, how much is difference? 1. For this, there is no difference. For this, how much is difference? 1. So 1 plus 1 plus 1. So total 3. So your error is 3 for this particular model. Does it make sense? So we are calculating the error. What we are calculating? What we are calculating? We are calculating how much error, right? So for that, what we have seen, the calculation for this particular y hat means for this particular model, your answer is 3. Your error is 3. Makes sense?
Yes.
Okay. Now coming to the next one. See, this is what we are showing here. Okay. Now see this one. Okay. We are saying that instead of this model formula, I am writing now y equal to 2x plus 1 in the next slide probably. Yes, you see here. Now I have given, okay, your y hat equal to 2x plus 1. Now you see your model is performing well, or your error is coming better or lesser. So what you are doing? Y hat, you are calculating 3, 5, 7, 9 here. 1 plus 1 plus, so this is for y hat equal to 2x. Now 2x plus 1 is this one, right? Which will actually give you 1. Basically, see here, y hat equal to, if you just calculate, it will come 1, right? So your error is coming as 1 here, whereas your error was coming as a 3 in the previous case. So by that way, you can understand the second model is performing better than the previous one. Makes sense, Neha and Sri Lakshmi. So
Yeah.
which model is performing well? The second
Ah.
model, because the error for the second model is 1. Should I repeat or does it make sense?
Yeah, it makes sense.
Yeah, okay. Sri, clear, right?
Yes, yes, sir.
If you don't understand, please let me know. I know that you did not cover this maths in your early days probably, but these are very basic things I'm talking.
Yeah.
Yeah. Okay, let's move on to the next one. Okay, now, now very important thing is we need to calculate what is efficiency or what is R2 calculation. This is very important. Okay. 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 Now, what is R2? Right? R2 is called a coefficient of determination. Okay. So by this way, we can understand what is the efficiency of a model. So initially we understand what is the error of the model, right? So error of the model we understand which model is performing well for the linear regression. Now we want to know what is the coefficient of determination, means which model is performing well. Okay, which efficiency of the model is high. So what is the input has been given? This the similar kind of x and y has been given, and it has told that in the model is working like that, y hat equal to 2x plus 2. So this is the way the model is working. Okay. Now we need to find out. So what this is the given data which has been given. I have written here. We have written that, okay, the prediction is 2x plus 2. Till this point, no question, right? We have written whatever is our problem statement. Now, first thing
Yeah.
what we have done, we have calculated the predictive values, right? So predictive values is y equal to 2x plus 2. So the way we have done earlier, we have just put the x values here, right? X is our input. So we will get some output. So this is the actual and this is the predictive values, right? So we'll get some output, right, for this particular model. So we are getting these values. Till this point, no question, right? Step 1 is clear. Yeah. Okay.
Yes.
Yeah. Now, next one is you need to make the difference, actual minus predictive. Y minus y hat, which we have done in earlier figures. So we are doing it. Yeah. And then we have calculated also error square. That's fine. We are doing error square also. We are just keeping it because in future you can see why error square they have done. We'll come to know in due course. But just think that y minus y hat square, we have done it here. Now we are saying that how much is total errors, right? So we are calculating the total errors from here, right? So total error is 4. Till this point, no question, right? We know everything till this point. Step 2 is
Yes.
clear. Yeah. Okay. Now step 3 is important. Step 3, what we are saying that we are actually doing the mean of y. What is y, sir? Y is actual. So we are actually doing all plus and then divide by 4. So we are getting 4. So that is the mean of y. Okay. So our calculation is this one. So total variance, because we are trying to get r, right? R square, right? So r square, actual formula of r square is 1 minus total number of error divided by total sum of squares. So to achieve that, we are doing all these things. Now we need to see what is SSE and what is SST. So first, let us concentrate on SSE. SSE we have already got, right? So total number of errors, whatever the error information is, we have got it, which is 4. Now to calculate the SSE,